Hello, algebra class. Today's video is on 6.1 to 6.3 review. Tomorrow you're gonna have a quiz. Keep an eye on your teams. Your quiz will be on Teams tomorrow, and it's gonna be covering 6.1 to 6.3. You got until next Tuesday to finish the quiz. There'll be no video tomorrow. Okay, so we did this quiz yesterday, 6.1 to 6.3 quiz. We did 1 through 14. Let's go through them now. Starting with number 1. Okay, so we got the square root of 20. Square root of 20. Okay, so we are trying to think of product with a perfect square. So in this case, 4 times 5. 4 being the perfect square. Your answer is 2 square root of 5. 2 square root of 5. So 20 can be expressed as 4 times 5, which is equal to the square root of 4 times the square root of 5. And simplified down is 2 square root of 5. Number 2, this is division, the square root of a division, 11 over 81. So the square root of, which is equal to the square root of 11 over the square root of 81. Square root of 11 is, cannot be simplified, but square root of 81 is 9. Number 3, you're simplifying 4 minus the square root of 12 divided by 2. All of it is divided by 2. So with number 3 now, you've got 4 minus the square root of 12 can be expressed as the square root of 4 times 3. And the square root of 4 times 3 is the square root of 2, or 2 times the square root of 3. So the square root of 4 times 3 can be expressed as the square root of 4 times the square root of 3, which simplifies down to 2 times the square root of 3. Now this can be simplified as 4 over 2 is 2, and 2 square root of 3 over 2 is square root of 3. So if you see this 4 over 2 is 2, and this 2 square root of 3 over 2 is the square root of 3. Number 4, similar simplifying radical expressions. You have -6 plus the square root of 45. All of that is divided by 3. Okay, so we're going to focus on the square root of 45 first, which is 9 times 5. 9 times 5 is 45. Now, why do we choose 9? Because 9 is our perfect square again. So thinking of our perfect square of square root of 9, we can simplify that down to 3. So next step, we show that the square root of 45 can be expressed as the square root of 9 times the square root of 5. Everything else stays the same. -6 plus that, and all of it's divided by 3. And the next step, when we simplify the square root of 9, you can see that we're down to 3 square root of 5. 3 square root of 5. Okay, final step is you've got -6 over 3, which is -2, and 3 square root of 5 over 3, which is the square root of 5. Number 5. Here you're given x2, y -3, and z 6. x2, y -3, and z 6. And what you're asked to do is determine what the expression square root of x plus y squared times z. So there's both substitution and simplifying the expression. So substitute your 2 in for x, your -3 in for y, and your 6 in for z, which would be your first step. And you want to see if you can simplify anything in the radical first. You've got this squaring going on here, you got the multiplying by 6, and you end up with 2 plus 54. 2 plus 54. Then continue on, you add the 2 plus the 54, you get 56. Now the square root of 56 can be broken down as 4, 2 times 2 times 14. So your final answer is going to be 2 square root of 14. 2 square root of 14. So you want to think of your perfect squares again. 4, square root of 4, square root of 9, square root of 16, and so forth to simplify your radical. 4 times the 14, square root of 4 times the square root of 14, 2 square root of 14 is your answer. Number 6, same thing. We're given x is 2, y is -3, z is 6, and you are asked to simplify the square root of 3 times x times z minus the y squared. Minus the y squared. So again, as I mentioned in this book, the book loves these substitution evaluating expression, because you do a lot of that as you get on into your next algebra class. So you can see that you've got your 2 in for x, your -3 is in for y, and your 6 is in for z. So then whatever you can do to simplify into your radical, go ahead. -3 squared is 9, and 3 times 2 times 6 is 36. Now, if you subtract the 9, you end up with 27. Okay. Now, what you want to do at this point is you want to think, how can I find a perfect square times something to get that 27? In this case, it's 9 times 3. 9 times 3. So 3 times 3 times 3 is 27. Your answer is 3 square root of 3 for number 6. 3 square root of 3. Okay, so you can see that I pulled this keys, shows every step, and helps break it down for you. Next, we have properties of exponents. Number 7, 3 squared times 3 to the 4th is equal to, same base now, so you're going to add the 2 exponents, 2 plus 4, you get 3 raised to the 6th. 3 raised to the 6th. Show your answer using exponents on this section. Number 8, you have k to the 4th raised, all of it's raised to the 3rd. Okay, so you got a power to a power. So what we're doing is we're multiplying 4 times 3, k to the 12th. Number 9, 4 times y, all of it raised to the -2 power. -2 power. So you got that negative exponent. So you want to attack that first, and that's going to be 1 over 4y raised to the 2nd, which is equal to, now what we have here is we have a product. All of this is raised to the 2nd power. So each of these items inside here is going to get the power. Okay, the 4 gets the power of 2, the y gets the power of 2, and your final answer is 1 over 16 y squared. 16 y squared, and that would be number 9. Moving on to number 10. Likewise, division, but it's raised to a power. So again, you have a numerator, r, divided by a denominator, 2, and all of this is raised to the 3rd power. Okay, so what we're going to do here is We're going to take this numerator, r, and we're going to raise it to the third power, r to the third. Then we're going to take the denominator to the 2 and raise it to the third power, 2 to the third. Final answer, r to the third over 8. Number 11, the cube root of 27. Cube root of 27. Okay, and that answer is 3. What number, when you multiply it together 3 times, gets you 27? In this case, it is 3. Number 12, rational exponents. You're looking for the fourth root of 16. Fourth root of 16, and that answer is 2. So what number, when you multiply it together 4 times, gets you that 16? In this case, it's 2. Positive square root of, or fourth root of 16 is 2. And the last two today, number 13. 13 is 512 to the 2/3. So we're going to take 512 to the 2/3. Basically, we're looking for the third root of 512. Then we're going to square it. Okay, so we're looking for the third root. That's what that 3 means. And we're going to try to square it. Okay, so we're looking for the third root of 512. Then we're going to square that. Okay, so third root of 512 is 8. Okay, so 8 times 8, 64. 64 times 8 is 512. Okay, so third root of 512 is 8. Now we're going to take that 8 and we're going to square it. So 8 times 8 is 64. So when you have these rational exponents, 2/3, okay, so when you see this one, it's actually, it's hard when they type that in. It is a 2/3, okay? The 2 divided by 3. So basically we're looking for that third root of 512, and then the 2 indicates the power, okay? Yeah, you take it 2. And lastly today on 6.1 to 6.3 quiz is this question down here, 4 to the 5 halves for number 14. 4 to the 5 halves. Okay, so we're basically looking for the square root of 4, and then we're going to take it to the 5th power. Okay, we're looking for the second root of the square root of 4, and then we're going to take it to the 5th power. Well, that's a perfect square. The square root of 4 is 2. And 2 to the 5th power is 32. Okay, it's a short video on quiz review 6.1 to 6.3. Hopefully you found this interesting and helpful. And be ready for your quiz, which will be sent out to you tomorrow. Not sure how many questions, but it's going to be short. If I don't talk to you again, have a great weekend. We missed you a lot, and we hope to see you guys soon. Take care now. Bye-bye.